Rotations in the coordinate plane. There are some rules for rotation. All the points in a figure must rotate together, including the vertices. All the points comprising the figure follow the same rule. So we can determine the effect on the figure by investigating the effect on a single point. And that will then be the same for all the vertices and the line segments connecting them. We begin with rotations about the origin, or the point 0, 0 of the graph. Remember, any positive rotations represent anti-clockwise or counterclockwise rotations, and any negative rotations represent clockwise rotations. Let's begin by rotating 90 degrees in the coordinate plane. The diagram shown here to the right represents a 90-degree rotation, anti-clockwise or counterclockwise, of point A about the origin. Our image is point A prime. So our point A is 3, 4, and A prime is negative 4, 3. This point is used as an example. Rotate another point to discover a pattern. Another point that could be used is point B, negative 1, negative 2, right here. After a 90-degree rotation, point B prime will be 2, negative 1. So let's look. We have 3, 4 for A, negative 4, 3 for A prime. We have negative 1, negative 2 for B, and 2, negative 1 for B prime. Well, we definitely are switching X and Y around, and then the first coordinate, or the new X coordinate, is changing signs. So this leads us to a generalization for all points in the plane. The result of a 90-degree rotation of any point about the origin is xy becomes negative y comma x. You flip x and y around, and what was originally the y coordinate becomes the opposite. So notice the y here was negative 2. It became the first coordinate in our image, and the sign switched, and it became positive. The original x coordinate remained the same, but it just moved to the y coordinate position in both points. Now let's look at rotating a figure 180 degrees in the coordinate plane. The diagram shown to the right represents a 180-degree rotation of point A about the origin. Our image point is A prime. The coordinates of point A are 3, 4, and after rotating it 180 degrees, the coordinates of point A prime are negative 3, negative 4. This point, 3, 4, is used as an example. Rotate another point to discover a pattern. Another point that could be used is point C, negative 1, positive 2. After a 180-degree rotation, C prime would be 1, negative 2. Let's do a comparison. A was 3, 4. A prime was negative 3, negative 4. Point C was negative 1, 2, and point C prime was 1, negative 2. So the digits remain the same, but their signs change. Like it went from positive to negative, and this one it went from negative to positive, positive to negative. So it appears that a 180-degree rotation keeps the numbers or the values in the x and y position the same, but their signs change. So this can be generalized for all points P in the plane. The result of a 180-degree rotation of any point about the origin is that xy, the original coordinates of the point, become negative x comma negative y. Again, all it is keeping the numbers in the same positions, but changing the sign that was originally in front. If it was originally negative, in the image it will be positive. If it's originally a positive, then in the image it will become a negative. Now let's discuss rotating a figure 270 degrees in the coordinate plane. The diagram shown to the right represents a 270-degree rotation of point A about the origin. The image is the point A prime. So we took each of these points and we rotated them 270 degrees anti-clockwise or counterclockwise about the origin. So our original point right here for A is 3, 4, and then after rotating it 270 degrees anti-clockwise or counterclockwise, we end up at A prime down here, which is 4, negative 3. This point is used as an example. Rotate another point to discover a pattern. Another point that could be used is point D, negative 2, negative 3, down here. After a 270 degree rotation, anti-clockwise or counterclockwise, we end up at D prime, right here, which is negative 3, 2. So we were at 3, 4 for A, and A prime was 4, negative 3. D was negative 2, negative 3, and after rotating it, it became negative 3, 2. Well, it looks like the X and Y switched places and the sign of our new Y, or our original X value, changed. So this can be generalized for all points P in the plane. The result of a 270 degree rotation, counterclockwise or anti-clockwise, of any point about the origin is that xy becomes y comma negative x. So the x and y coordinates switch positions, and then the sign of the original x value becomes the opposite. So this negative 2 became positive 2 when it was after it was rotated, and this original 3 became a negative 3 in the rotation. Now let's discuss rotating points or objects negative degrees in the coordinate plane. The diagram shown to the right represents a negative 270 degree rotation of point A about the origin, and the image is point A prime. So it's a negative degree, so we're going clockwise, and 270 degrees means we're going all the way around from quadrant 1 to quadrant 2. Of course, this corresponds to a rotation of 90 degrees anti-clockwise or counterclockwise, because negative 270 degrees plus 360 is equal to 90. So 3, 4, the original coordinates of point A, becomes A prime, which is 4, negative 3. That's the same as the A prime that was found with the 90 degree rotation about the origin. This can be generalized for all points P in the plane. The result of a negative 270 degree rotation of any point about the origin is that xy becomes negative yx, which again corresponds to the same rule that we derived for a 90 degree rotation about the origin.